ओके सो हेलो एस्पिरेंट्स, आई होप ऑल ऑफ यू आर डूइंग परफेक्टली वेल। तो बेसिकली जो आज का क्लास है उस कोर्स में हम लोग मोस्टली प्रॉब्लम सॉल्व करेंगे रोटेशनल मैकेनिक्स के ऊपर। तो आई थिंक फर्स्ट क्वेश्चन आप लोग के सामने ऑलरेडी आ चुका है, तो हम लोग विदाउट एनी फर्दर ड्यू क्वेश्चन को शुरू करेंगे। बट बिफोर वी इनिशिएट द क्लास, जो भी बच्चों ने अभी तक क्लास ज्वाइन किया है एक बार मुझे कमेंट सेक्शन पे बता दो कि क्या मेरा आवाज़ आप लोगों को ठीक से सुनाई दे रहा है या नहीं। एंड दूसरी बात कि इफ़ यू ऑल कैन सी द स्क्रीन प्रॉपरली और नॉट, दैट्स अ वेरी इंपॉर्टेंट थिंग। इफ यू कैन सी द स्क्रीन प्रॉपरली and if you can hear my voice properly, then I think we are very much good to go. We can start the class. बताइए, ऑल गुड, ऑल क्लियर, शुरू करें? बताओ। ठीक है, चलो फिर क्लास शुरू करते हैं। एंड आई थिंक फर्स्ट क्वेश्चन हमारे सामने है। फर्स्ट क्वेश्चन हमारे सामने है। क्वेश्चन में क्या बोला गया है हम लोग थोड़ा सा पढ़ेंगे। बोला गया है द डिसेंडिंग पुली shown in figure 10.E7 has a radius of 20 centimeter. Moment of inertia is I, suppose. The fixed pulley is light and horizontal plane frictionless. So this plane is frictionless and this pulley is actually light. So this pulley is not rotating, but this one can come down. And this one can rotate as well. So find the acceleration of the block if the mass is 1 kg. Find the acceleration of the block if the mass is 1 kg. So first of all, you have to understand that just because this pulley has a mass, the tension on both the pulley on both the sides will not be same. Just because this pulley has a mass, the tension on both the sides will not be same. Suppose over here the tension is actually, this is on tension on this pulley, tension on this pulley. This is T1, T1. This is tension on this and this, it's T2. The same tension I get. Okay, so that's your T1, T1, this is T2, T2. Fine, ये भी T2 है जो इस दीवार के ऊपर लग रहा है, ये भी T2 है जो इस पुली के ऊपर की तरफ लग रहा है। Now, just because of course motion इस तरफ नहीं हो सकता at any cost, so of course the mass of this pulley has to be quite large and that's why ये नीचे जाएगा and as a result of which block इस तरफ आएगा। अच्छा, यहाँ पे ये T है, ये massless है, तो definitely यहाँ पे भी तुम्हारा T1 होगा, यहाँ पे भी तुम्हारा tension T1 होगा। Now just write down the equations of motion. If this one has a mass, so नीचे mg काम करेगा, ऊपर normal reaction, so this force 2 will balance each other, so we are not at all concerned about this vertical forces, but horizontal force will actually generate the motion. So let's just write down. Then this one has a mass of m1 and this one has a mass of m2. This one has a mass of m1, this one has a mass of m2. So of course in the downward direction I'm having m2 into g, m2 into g. So tell me, m1 into a, mass into acceleration is equals to force. इसके ऊपर से एक ही force काम कर रहा है, that is T1. So T1 should be is equals to m1 into a. That's one thing. Now between these two tensions, of course, this pulley is coming in the downward direction. This pulley is coming in the downward direction. So m2g is greater than T1 and T2. Okay, what will be the acceleration of this one and this one? Can anybody tell? अच्छा, ये पुली अगर x डिस्टेंस ऊपर जाएगा तो कितना रस्सी खुलेगा? इधर x, इधर x, 2x अमाउंट, सो ये पुली 2x अमाउंट इधर हटेगा, तो इसका डिस्प्लेसमेंट अगर x है, इसका डिस्प्लेसमेंट 2x होगा। ठीक है, सो इफ द डिस्प्लेसमेंट, ये बहुत आसान है सोचना, इफ द displacement of m2 is x, then that of m1 is 2x. Therefore, just do the differentiation. Velocity of m1 of m2 लिखते हैं पहले. वेलोसिटी ऑफ m2 तुम्हारा क्या है? अगर dx dt है तो वेलोसिटी ऑफ m1 विल बी ddt of 2x, that is 2 into dx dt. And again acceleration ACCELERATION of m2 अगर तुम्हारा है, इसका फिर से डिफरेंशिएशन, सो d2x dt2, then ACCLERATION acceleration of m1 will be differentiation of this thing again with respect to this, so 2 into d2x dt2. So whatever be the acceleration of mass m2, the acceleration of mass m1 will be twice of that. I have taken the acceleration of m1 is a, so acceleration of m2 will be half of that. Very good. So I can just write down, for this case it's coming in the downward direction, so m2g minus t1 plus t2. This is the downward force, these two are the upward force, so t1 plus t2 should be equals to m2 into a by 2. And we can write down the rotational equation. We can write down the rotation. So m2g will not, I'm finding out the torque with respect to the center. m2g is passing through the center, so will not create any torque. Torque will be due to t1 and t2. Now tell me how much torque it will generate. So which one is greater? This is coming in the downward direction, it's coming this, so basically it has a rotational tendency along this direction. It has a rotational tendency along this direction, right? So T2 is greater in magnitude. Okay, if it has a rotational tendency along this direction, then I can say T2 is greater in magnitude. So T2 minus T1 into the radius of this pulley, that is R, should be actually equals to its moment of inertia into alpha. Okay, that means I can write T2 minus T1. Achha, from this equation I need to tell you something. Before I write this, from this equation I have got something to tell you, that is T1 plus T2 is actually equal to then m2 into g minus a by 2. m2 g minus m2 into a by 2. That's all I got. Now from there is another expression which is quite interesting and important, that is T2 minus T1 into R. The torque should be equals to moment of inertia of this pulley into its radius, into its alpha. So alpha I have written it down. Now you know that alpha is equals to what? Acceleration of this pulley divided by R. Alpha into R is equals to its acceleration. So alpha divided by R should be equal to this a by 2. Or alpha omega cross R is equals to V cross R is equals to acceleration of that pulley. That's all. So alpha can be written as a by 2R. Alpha can be written as a by 2R. So I a by 2R. I into a divided by 2R. And here I have T2 minus T1 into R. That represents T2 minus T1 is actually equals to IA by 2R square. So I know T1 plus T2 is this, and T2 minus T1 is IA by 2R square. IA by 2R square, T2 minus T1. Now if I add these two equations, T1, T1 cancel out, and I'm going to get T2 is equals to 2T2 equals to this plus this. So I just have to name the equation. Equation number, this is 1. This is equation number 2. This is equation number 3. Just do the calculation. Adding 1 and 2 and 3. Just let me write it down. Adding 2 and 3. What I'm gonna get? Adding equation 2 plus 3, I'm getting a very important result, which is if you add this plus this, it's 2t, that is m2t2, that is m2g minus m2 into a by 2, m2 into a by 2, and of course plus ia by 2r square plus I into a divided by 2r square. So from here T2 I'm getting as m2 into g by 2 minus m2 into a by 4 plus I into a by 4r square. That's the value of my T2. If I put this value of T2 over here and T1 from here, putting T1 and T2 in this equation 2, I'm gonna get the answer. T1 equals to M1A. Now I can write it here. Now putting, this is from 3, so this equation has to be equation 4. Putting T1 and T2 from 1 and 4 in equation 2, we get, in equation 2 you can write down the T1 and T2, or equation 2, or better in equation 1, you put it in equation 1, you will get it a nice result. In equation 1 or in equation, not in equation 2, it will be linear result. In equation 3, suppose in equation 3 we get, what is your T1? T1 is T2. What is your T2? T2 is actually equals to your m2g by 2 minus m2 into a divided by 4 plus I into a divided by 4r square. This is your T2, minus T1 is actually equals to m1 into a, m1 into a, that is actually equals to ia by 2r square, ia by 2r square. I think it's very easy to find out the acceleration. Take this term, this term, this term, this term on one side and this on the other side, and from here I can get the acceleration as, from here I can just find out the acceleration A as actually equal to, let me calculate it over here, m2g by 2 divided by, if I bring all the terms over here, it will be equals to I by 2r square, okay, minus I by 4r square, okay, then plus m1 plus m2 by 4. Acha, I by, okay, just multiply 2 and 2, so it's 4. 2I by 4r square, okay, so fine, it's good, it's I by 4r square. So m1 plus m2 by 4 plus I by 4r square. m1 plus m2 by 4 plus I by 4r square. So it's, just write down m2g and just multiply this 2 over here. So m2g divided by, if I multiply this 2 in the numerator and denominator, I'm going to get, or if I just multiply 4 on the numerator and denominator, so it's 4m2g, 2m2g, and here I'm going to get I by r square, m1 4m1 plus m2 plus I by r square. 4m1 plus m2 plus I by r square. So I think you all can see it. Just let me just, yeah, now I think you all can see the expression. Just put the values of m1, m2, I and r square and tell me what answer you are getting. See, the moment of inertia they mentioned as 0.2. Radius is also 0.2. Moment of inertia 0.2, radius is 0.2. So let me just do the calculation. 0.2 square, what we are getting inverse, what we are getting multiplied by 0.2, what we are getting plus mass of m1 and m2. Okay, m2 mass of the pulley is, okay, I need the mass of the pulley, which I don't have currently. Okay, mass of the pulley I need to find out. Can you tell me what is the mass of the pulley? These pulleys are basically disc, right? Pulleys are basically disc. So if it's a disc, so its moment of inertia is mr square by 2. Mr square by 2 is equals to I. M2 r square by 2 is equals to your I. So from here M2 is actually equal to 2I by r square. That's all. M2 equals to 2I by r square. That means r is actually your 0.2. So 0.2 divided by 0.2 square. So it's 5 multiplied by 2 is 10. I by r square is 5, I must mention. This is, okay, this is 5, this is 10, m1 is 1 kg, they mentioned. It's 1 kg, m1 is 1. Good, now do the problem. So 10 plus 5, 15, 15 plus 4, it's 19 in the denominator. 19 in the numerator, 2 into m2 is 10 into, I can take g 9.8. Good. 2 into 10 into 9.8, whatever I'm getting, divided by 90. 10.31, 10.3. The answer is approximately 10.3. So you must get 10.31. This is meter per second square. This is the acceleration of the block. This is the acceleration of the block. It's an easy question. It's not tough. I would not say this question is tough. So that's an easy question. From this expression, you can find out the acceleration, that is 2 mg or mg divided by 2, m2g divided by 2, whole divided by, I can write it here, that I by 2r square plus m2 by 4 minus I by 4r square plus m1. 2I by 4r square minus I by 4r square, that is I by 4r square. Just remove this one and just multiply 4 on numerator and denominator. So if you multiply 4, I'm going to get 2. If you multiply 4, this 4 will go, this 4 will go, and here I'm going to get 4. 4m1 plus m2, 4m1 plus m2 plus I by r square, and ऊपर में 2m2g, 2m2 into g. Done. So this is the thing which I have done. All this calculation is here. So that's an easy question. That was an easy question. It was a good question as well. Can we do some next question? Question number 38. Okay. Yes, we have done. So I can again turn on the ticker. Yes. बताओ. Question number 38 कैसे करोगे बताओ. The pulley shown in figure 10.E8 has a radius of 10 cm and moment of inertia of 0.5 kg per meter square about its axis. Now assuming the inclined planes to be frictionless, calculate the acceleration of 4 kg block. Acha, tell me in which direction the tendency of motion will be. Of course, this 4 kg, this is 2 kg. The tendency of motion will be along this direction. Anybody can see. The tendency of motion will be along this direction. As a result of which, just because this is 4 kg, this is 2 kg, 4 kg is greater than 2 kg, the tendency of motion will along this direction. Here I can tell you the tension is, suppose I'm telling you the tension is here I can say the tension is T1. Here I can tell you the tension is your T1, T1. Here the tension is your T2, T2. Of course, the pulley is not massless, so on both sides the tension, the pulley has a different tension. So of course, it has a tendency of rotation along this direction, so this tension will be greater in magnitude. This tension, so T2 should be greater than T1. T2 is greater in magnitude than T1 because it's coming in this direction. The pulley is rotating clockwise. As a result, T2 will be greater. So let me just write down the equations of motion. Here I'm having M1. If this block is basically having a mass of M1, say, and it's frictionless, right? This block is having a mass of M2. So this one is having a force on this side as M1 g sine theta M1 g sine 45 when I'm just writing it theta, and this one has a force on this side that is M2 g sine theta. M2 g sine theta. Of course, you're having a force. Actually, the force is along this direction M2g. So on this direction it's M2g sine theta. On this direction it is M2g cos theta. But M2g cos theta will be balanced by the normal reaction. So I'm not at all concerned. I'm not at all concerned. So yes, I'm only concerned about this force. M2g sine theta. Good. So just write down the equations of motion now. So I can tell that for this block is going up, this block is going down, this block is going up, so T1 is greater than M1g sin theta. So T1 minus M1g sin theta T1 minus M1g sin theta is equals to M1 into acceleration. For this case, M2g sin theta plus T2, minus T2, because this is coming down, T2 is upward, so minus T2, T2 is less, giving you M2 into A, and apart from that, this one is rotating, T2 is greater than T1, so T2 minus T1 into R, that is the torque, this should be equals to moment of inertia of this pulley into alpha. That means moment of inertia of this pulley, acceleration A divided by the radius of the pulley. So from here I'm getting T2 minus T1 is actually equals to IA by R square. From here. So I have three equations to solve. First, second and third. Very easy thing. I think all of you can solve it. Okay, what I'm gonna do is just take negative of this equation, positive of this equation, negative of this equation, negative of this equation, and then add them. Okay, fine. Just do one thing. Add these two equations and tell me what you're getting. Add this two equations, adding 1 and 2. Just do one thing. Equation 1 plus equation 2. Just do that thing. What you're gonna get? So T1 minus T2. T1 minus T2. You're getting. Then, okay, this is your T1 minus T2. You're done. Now here M2 G sin theta minus M1. So M2 minus M1 G sin theta should be equals to, if you add these two equations, M1 plus M2 into A. That's all I'm gonna get. Now you must notice T2 minus T1 is IA by R square. So T1 minus T2 is negative of IA by R square. So on the next page, I can just write down on the next page I can just write down negative of, see, I know that T2 minus T1 is IA by R square. So T1 minus T2 is minus IA by R square. So minus IA by R square. That's good. Plus M2 minus M1 into G sin theta plus M2 minus M1 into G sin theta should be actually equals to your What is m1 plus m2 into a? m1 plus m2 into the acceleration a. Now I think it's very easy to find out, because just bring it on this side and just divide it. So you're going to get m2 acceleration a is actually equals to m2 minus m1 into g sine theta whole divided by this m1 plus m2 plus I by r square. Good. Now tell me what this thing. m2 is 4 kg, m1 is 2 kg. So this is 2 into 9.8 into sine 45 is 1 by root 2 whole divided by 2 plus 4 plus, what is the moment of inertia they mentioned in the question? 0.5, right? Means half. What is the radius of the pulley? What is the radius of the pulley? It's 10 centimeter, 0.1 meter. So 0.1 square. Okay. 0.1 square, whatever I'm getting inverse, whatever I'm getting multiplied by 0.5. That is 50. 50 plus 6, नीचे 56, ऊपर 2 into 9.8, whatever I'm getting divided by root 2. So it's 13.859. And you are getting divided by 56, that is 0.247. 0.247 means basically 0.25. So this thing should be equal to 0.25. So this is 4 minus 2 into 9.8 into sine 45 whole divided by m1 is actually equals to your 2 plus 4 plus in moment of inertia 0.5, radius is 0.1 square. Well, of course that's 0.25 meter per second square. If they have asked you the tensions over here and here also, that you can also determine, because you know A, you know I, you know R, so you know T1 and T2, everything you know. You can find T2 from this equation, you can find T1 from this equation. Find T1 and T2 by yourself. With the help of equation, you can find T1 from equation 1 and 2. Respectively. Done. After that, what they have mentioned, solve the previous problem if the frictional coefficient between the 2 kg block and the plane below is 0.5 and the plane below 4 kg block is frictionless. So solve the same problem again if there is a friction. If there is a friction, of course, you have to write down all the force again. So this direction you will have a force, that is m1 g sine theta. Here in this direction you will have a force m2 m1 g cos theta. Here you have a force normal reaction, that is n, and on this case you have a force this direction. It has a tendency of motion in which direction? You have to determine the tendency of motion. This is greater in magnitude, so it has a tendency of motion upward. So frictional force will go downward. It has a frictional force along this direction F. It has a tendency of motion to go upward. Of course, this one is rotating along this direction. And of course, this one has a weight. This one has a weight. m2 g sine theta. Of course, this floor is frictionless, so I don't have to consider. So this is m2g cos theta, normal reaction will cancel each other, so I'm not considering that thing. Here also m1g cos theta, normal reaction will cancel each other, but this normal reaction I need for to find out frictional force. That's why. So first of all, the frictional force F is actually equals to mu into m, that is mu into m1 g cos theta. Again, this one is going up, so definitely here my tension is T1, T1. This one is going down, so it's T2, T2, and of course, um, so this one T1 is greater in magnitude than m1 g sin theta and the frictional force. So I can just write it down. That T1 minus m1 g sin theta plus frictional force. We must give you the acceleration of this, that is m1 into a. Apart from that, I can just write down for this case, it's m2g sin theta minus the tension T2 must provide you m2 into the acceleration a, and for the rotation of this, I must tell you T2 minus T1 into r is your I into alpha, that is I into a divided by r. And from here I can tell T2 minus T1 IA divided by r square. Done. Okay, so it's been solved quite a bit. What you do is, the problem is extremely simple. Just find out, just put f from equation 1 in equation 2. So say this is my equation 1, this is my equation 2, my equation 3, my equation 4. So from 1, put the value of f in here, then find T1. Okay, from 3, find the value of T2. Or just do one thing. From 1 and 2, you can write one equation. Adding that equation with 3, you will get an equation. Okay, fine, just write it. I can just simply say from 1 and 2, putting f from 1 in 2, putting f from 1 in 2, from equation 1 I'm putting the value of f in equation 2, I'm getting an expression that is T1 minus m1 g sin theta plus f, m1 g sin theta plus f is your mu m1 g cos theta should be actually equals to m1 into a. That's say my equation number 5. That's say my equation number 5. Now adding 3 and 5, then I'm doing adding 3 plus 5. If you do the addition, then you're gonna get, okay, in 3 you have m2g sin theta minus T2, m2 g sin theta minus T2, and from this 5 the left hand side has plus T1 minus m1 g sin theta minus mu m1 g cos theta should be equals to, add these two terms, like this is your m2 into a, this is your m1 into a, so m1 plus m2 into a. Now here you have T1 minus T2, T2 minus T1 is IA by r square, so T1 minus T2 is minus IA by r square, so this is T1 minus T2 is minus IA divided by r square. So this is m2 g sin theta minus IA divided by r square minus m1 g sine theta minus mu m1 g cos theta, that is actually equals to m1 plus m2 into the acceleration A. Now just put the values everywhere. Here I am using which equation? 4. Using 4 I have got this term, because t1 minus t2 I have put minus I by r square. So here you can just write down what is the acceleration A. So there I find no term. Achha, sin theta is 1 by root 2, g suppose 9.8, and m1 is your what? 2 kg. Good. So just do one thing. Take these 3 terms and put this one over here. You will get something. Okay. So I'm writing here m2 minus m1. What is my acceleration then? Acceleration A should be equals to m2 minus m1. Here m2 minus m1 g sine theta. So this term has been completed, minus mu m1 g cos theta divided by m1 plus m2 plus I by r square. I by r square. Now in the previous problem we have deduced that I equals to what? Okay, it's been given that based on the frictional coefficient between the block 2 kg and okay 0.5. 0.5 is mu. 0.5 is mu. Good. And here moment of inertia 0.5, radius is 0.1. Let me write down all the expressions here. I is 0.5, R is 0.1 meter, I is 0.5, R is 0.1 meter. Acha, M1, 2, M2 is 4, mu is 0.5, theta is 45. Just tell me what it will get. What will you get? So the mostly I'm going to get m2 minus m1, it's 4 minus 2 is equals to 2 into 9.8 into sine 45 is 1 by root 2 minus mu is half, m1 is again 2, g is 9.8, cos theta is 1 by root 2. So 2 cancels out, 9.8 by root 2, 9.8 by root 2, so 2 into 9.8, 2 in minus 1 is equals to 1, so 9.8 divided by root 2 in the numerator. In the denominator I have 4 plus 2 equal to 6 plus this I by r square is equals to what? I think 50. So this is 50. So it should be 56. Now 9.8 divided by root 2 divided by 56. 0.124 or 0.1237. 0.1237. Or I can write this is 0.124. This is your 0.1237. That's the acceleration. Meter per second square. Done. So these are the types of questions, and these are very nice questions. You can solve it for yourself. These are very nice questions. So you know over here also that T2 is greater than T1 because this mass is large. M2 greater than M1, M2 greater than M1 M1, that implies T2 greater than T1. T2 greater than T1 means tendency of motion is clockwise. Okay, done. So we have solved this question as well. Now what we can do is that there are some ladder sort of questions, some ladder and pulley sort of types questions. There are some questions kind of ladder and stuff like that. So let's just tell you questions of those kind. So there are some questions like ladder and pulley. I'm sorry, ladder resting over some vertical wall. Okay, so in the ladder case, just let me write down. Just wait for a moment so that I can add the question. Uniform ladder of mass 10 kg of length 10 meter and mass 16 kg. Okay, rest on 37 degree of electrician weighing 60 kg climbs up 8 meter from the ladder. Fine, we have the question here. Fine. Okay. Now have a look. The question is here. It says a uniform ladder of length 10 meter and mass 16 kg. A uniform ladder of length 10 meter, mass 16 kg is resting against a vertical wall making an angle 37 degree with the vertical. Okay, wall the frictionless, but the ground is rough. The electrician weighing 60 kg climbs up the ladder. If he stays on the ladder at a point 8 meter from the lower end, what will be the normal force and the force of friction on the ladder by the ground? What should be the minimum coefficient of friction for the electrician to work safely? Good, it's a good question. How will we solve it? let's let's just write it down. I have a thing here. I will erase everything and then I'll write it here. Fine. Have a look. This is your ladder. This angle is not 53. In this question, this angle is actually 37. So I will just change this. This angle is not at all 53. This angle is 37. 37 degree. The angle is 37 degree. Okay. The weight of the ladder is acting from its center of mass, and the mechanic is standing here. So his weight is coming from, the mechanic is kind of standing here. So his weight is also coming from this point. His weight is acting along this direction, the weight of the mechanic. Okay, that is 60 into G, weight of this ladder, what they have mentioned as a 60 kg to 60 into G, weight of the ladder is 16, so 16 into G, so this is, I can just write down, erase this stuff. And I can write it down that this is 16 into G. This is 60 into G. I can write it like this. Or maybe the mass of the ladder can be taken as, mass of the ladder can be taken as M, and mass of this can be taken as M2. By that way as well I can write it. By that way as well I can write it. So this can be written as your M1G. This is your M2 into G. That's all. What they have mentioned in the question, okay, it's making an angle 37 degree with the vertical. The vertical wall is frictionless, but the ground is rough. So when the electrician is working, the ladder has always a tendency to fall like this, This wall has a tendency to come on this has a tendency to go on this, so frictional force will act on this. This is smooth, so no friction will come here. Fine. So now, what the first question they have asked, उन लोगों ने पूछा if you stays the ladder at all, what is the normal force and the force of friction on the ladder by the ground? What will be the normal force and the force of friction on the ladder on the ground? Okay. They have asked us to find out the value of N2 first. So we know that N1, just because forces on the on the horizontal direction has to be normalized. So N1, the normal reaction should be equals to force of friction. Force of friction, right? Then force of friction is equals to mu into normal reaction given by N2 here. Force of friction here is normal reaction over here multiplied by mu N2. That's one thing I know. Apart from that, not ये वाला हो गया. अच्छा, उस तरफ इधर की तरफ अगर देखा जाए तो N2 should be equals to what? N2 should be balanced by this M1G plus M2 into G. M1G plus M2 into G in the vertical direction. This force is downward, this force is downward, this is upward. So M1G plus M2G should be equals to N2. Right? This is one thing I know. Well, you know the value of M1 and M2, right? You know that M1, the mass of the ladder, is 16, and M2, mass of the electrician is 60. So basically this is your 16 plus 60 into G. So 76 into 9.8. 744.8, that's 745. That is your 745. The value of N2 is 745. Do you know the mu? Anna, they have asked to find the value of mu. Okay, fine. No, not to worry. Okay, can I just find out now? The ladder is in rotational equilibrium also. This is for translational equilibrium of the ladder. Now the ladder is also in rotational equilibrium. It's not rotating. Rotational equilibrium. So torque about any point will be 0. I am finding out the torque about B. So just because it's in rotational equilibrium, torque about any point has to be equal to 0. I am finding out the torque with respect to B. I'm finding out the torque with respect to B. It's in rotational equilibrium, so torque about any point has to be equal to 0. But I'm finding out the torque with respect to B. Okay, taking torque about B. So just write it down. Taking torque about B. Taking torque about B. So how many force do you have? And just write down the torque. So sir, if you take the torque, this force is actually passing through B, so there is no torque for N2. This force is along this, and this radius vector is along this. Can you tell me the direction between this angle is equals to what? This is 37, right? So this one has 53, value 53. This is 37, so this is 53. If this is 53, then this is 90. 90 plus 53. 3 plus 90, 143. So this is sine, this angle is 143. So it is from here to here. The ladder has a length of how much? 10 meters. So this distance is at a distance of 5. R cross F. So R into M1G into sine 90 plus 53 is 143. Plus for this one, it is 5 plus 8, that is 13. Sorry, it is just simply 8 because from the ground the electrician is standing at a distance of 8. So this is L by 2. This person is standing at a distance of 8 meters. So the distance D at which this person is standing from the ladder is R into M2G into sine, again it's making the same angle, 143. And what is the angle this one is making? So this is your R vector pointing along this is your N vector. Angle between these two is equals to what? Good. This is 37, right? So this total angle, okay, fine. If I say this is 90, if I say this is 90, if I say this is 90, this is 90, this is 37, so this is 53. This is 53, so I've just found out that this angle is 53 also. No, I need to find out which angle, brother. This is the direction of R vector. This is this. I have to find out this angle, right? But just find out this angle. This angle is actually equals to your 53. If this is your 53, so this is 180 minus 53. That is 127 plus this entire distance, the length, L into N1 into sine of 120, 180 minus 53. That is 127. That should be equal to 0. The resultant torque should be equal to 0. The resultant torque should be equal to 0. So just see, this is sine of 143. Sine 143 जितना आता है 0.6 cos 37 भी उतना ही आएगा. Sine of 143 and sine 37 का सेम वैल्यू आता है. Sine of 127 कितना आता है, cos 37 का उतना वैल्यू आता है. ठीक है. So let me just write it down. This torque has to be same. All the torques has to be same. So this is R cross F. If I do R cross F downward, this is R cross F upward torque. So this one is giving an upward torque, right? So this should be equal to this. I must write down. If you take the torque, so it should be like this. This torque is acting in the downward direction. This torque for this weight, torque is acting in the downward direction into the plane of the page. For this, it's up the plane of the page. So total torque should be equal to 0. Total torque should be equal to 0. Or for this, just tell me, it is into the plane of the page or out of the plane of the page. For this one, the torque is, I can say that for this one, the torque is into the plane of the page. So minus k cap into the plane of the page. So minus k cap R into G sine 143. This is minus k cap. For this one, the torque is positive plus k cap, positive z direction, should be equal to 0. Good. So from here on, I can write down, just multiply with a minus sign altogether. So L by 2 M1G sine 143 can be written as sine 37 plus this is R M2G sine 143 again sine 37, and this one, if you multiply the negative of length of that ladder into N1 cos 37 should be equal to 0. And after solving this, what I'm going to get, if you solve this equation, just let me just turn off my camera. If I turn off, then you can solve it and you can get an answer. Okay, from solving this equation, you can very easily find out the value of this normal reaction, right? We have a class at 11, so I will just discontinue the class from here. On the next class, we will again continue. I will discontinue the class from here. On the next class, we will again continue. Thank you very much. I will end the class over here. We have a class at 11, as you all know, and the PDF will be uploaded on the Telegram channel. Bye.